Hi, everyone. Sorry about that. The video cut out. So I'm starting on problem number 18, continuing the chapter 11 review of area. So the area of a rhombus is 348 units squared. So let's draw a rhombus. Remember, a rhombus has four congruent sides. It has diagonals that bisect each other. It has diagonals that bisect the angles. It has diagonals that are perpendicular, none of which we need for this problem. Area of a rhombus is equal to 1/2 diagonal 1 times diagonal 2. And what they've given us is the area, which is 348 units squared, equals 1/2. They've also given us the diagonal. One of the diagonals is 24 units, so 24 times the second diagonal, which gives us 348 equals 12 times diagonal 2. So diagonal 2 is equal to 348 divided by 12, which is 29 units. Draw a triangle PQR with angle P at 45 degrees. So here's my triangle. Didn't say if it was right or not, so I'm going to assume it's not. PQR. Angle P is 45 degrees, so we're going to say that's 45. PR is 10, and PQ is 3. Find the area of triangle PQR, so that's the whole triangle. So we have area of triangle. PQR is 1/2 the base times the height. So what we have, it looks like, is the base if I can have a perpendicular line for my height. Because remember, for this, the base has to be perpendicular to the height. That's very important. And so area of the triangle equals 1/2 our base, which is 10. What we need to do is find the height. So I'm going to draw in my height. And the neat thing is if that's 45, that's also 45. So x root 2. So basically, x root 2 is equal to 3. X equals 3 divided by root 2, which of course will never leave a root on the denominator, multiplied by root 2 over root 2, which is 1. We have 3 root 2 over 2. So it looks like my height is 3 root 2 over 2. So our area of our triangle is going to be, let's see here, 2 goes into 10 5 times. So that looks like it's 15 root 2 over 2 units squared. Okay. A square and an equilateral triangle both have sides equal length of 5. So let's see. So basically we have a square that has 5s on the side. All the sides are equal. And an equilateral triangle, which also has lengths 5. That equilateral triangles all have angles of 60. So if I'm going to find the ratio of areas, I'm going to need to, find the ratio of areas of the square to the area of the triangle. So what I'm looking for is the ratio of the area of the square to the area of the triangle. Area of a square, that's just going to be 5 times 5, so that's 25 units squared. The area of the triangle is a little bit different because what we have is 60, 60, and there's my 30. So this is 2.5, 2.5. So across from here is going to be 2.5 root 3. And then 2.5, same thing as saying 2 1/2, which is the same thing as 5 halves. So that's really my height. So the area of my triangle is 1/2 my base times my height, which is 5 halves. Let's grab that. 5 halves root 3. And so it looks like that's going to be 25. Area of that is 25 root 3 all over 4. So it's 25 divided by 25 root 3 over 4. Now for this, what I see that I need to do is we're going to divide that, and we're going to say that's 25 divided by. Well, dividing by, this is my dividing by, is the same as multiplying by the reciprocal. So that's going to be 4 over 25 root 3. So 25 cancels with 25, so I have 4. So actually the ratio of the areas is going to be 4 to root 3. So 4 to root 3. We're not leaving the root on the denominator, by the way, because it is a ratio. Okay. Given a right triangle whose sides have length 2, root 3, and 4, determine the length of the altitude to the hypotenuse. So, okay, so here's our triangle. Oh, it's a right triangle. 2, root 3, and 4. So what I notice about this right triangle is that this is double. So that only happens when you have a 30, 60, 90 right triangle. And so if that's 30, that's double. So 2. And what they want to know is this right here. This is 2 root 3. Thank you. What they want to know is this length right here. And so if this right here, that's an altitude, so it has to be perpendicular. And so that's a 30, which now makes this little angle in here a 60-degree angle. So if across from the 90 is equal to 2a, a is equal to 2 root 3 divided by 2 root 3 divided by 2. 2's cancel. We have root 3. Across from the 30 is your a. So therefore, across from here is root 3. So my answer is root 3. Find the area of a regular octagon with side length 4. Now this one you might need your calculator for. I know it says to skip this on the solutions at online, but let's see if we can do this. 2, 3, 4, 5, 6, 7, 8. Let's try to fix that. So let's see. What you need to know about this is, let's say, we need the sum. We know the lengths are 4. We need the sum of all the angles inside. So we're going to go 180 times n minus 2. So 180 times 8 minus 2, 180 times 6. So that's what, 1080? Okay, and if I take 1080 and I divide that by 8 sides, I'm going to get each side of my angle, or each angle, 135. So that's 135. Now, half of 135 is what? Is half of 135. So what I need to do is this. Split this up. And so you're going to need a calculator, because we know this is 2, and basically the area of this, any polygon, any regular polygon, the area is 1/2 ANS. And so what that does is it gives us 1/2 my apothem times the number of sides times the length of one side. The length of one side is 4. So let me see if I can move this over here. Let's see. Okay, so if you have your calculator available, what I need you to do is, after you take 135 and you divide that in half, you end up getting, what, 67 and a half? So this little angle in here is 67 and a half. So what we need is the apothem, which is this length right here. So, and we know that this is 2, okay? So this looks like a tangent problem where we have opposite over adjacent. So what I can do is I can say tangent of 67.5 is equal to x over 2. So x is equal to 2 times whatever tangent of 67.5 degrees is. You need to make sure that your calculator is in degrees when you do this. So basically you're taking tangent of 67.5 and you're multiplying that by 2, and I get 4.8. So my apothem becomes about 4.8. So that's 4.8. I can plug this in here. And so what we have is 2 can cancel into, let's say, 8, 4 times. So I have 16 times 4.8. And so the area of this octagon is about 77.3. And this is area, so units squared. You just need to be careful that because you're approximating, you just use the squiggly approximation for the equal sign. So one right triangle has legs 18 and 14, and another right triangle has legs 14 and 24. It looks like we have the same length in one of them. So if we have a right triangle that has a length of 14 and 18, and we have another right triangle that has a length of 14 here and 24, they want to know the ratio of the areas. Well, if the heights are the same, then we can say 18 to 24. And what that does is, well, we need to reduce. So I could start reducing by 3. 3 divides into 18/6. 3 divides into 24 by 8. I could still reduce that by 2. So that's 3 over 4. So the ratio of my sides is 3 to 4. So once I have the ratio of the sides, remember that you can always find the ratio of the areas by just actually doing the formula. So 1/2 base times height to 1/2 base times height. So let's check 1/2 base. Our base is, let's say, 18 times our height, which is 14. And then the other one is going to be 1/2 the base, which is 24, times the height, which is 14. So we go 18 times 14 divided by 2 is 126. And if we say 24 times 14 divided by 2 is 168. And if you have 126 divided by 168, you're going to end up getting, 3 to 4, which is our same solution, and we just checked. Cool. All right. So thanks for watching, and make sure you study for your chapter test. Thank you.